Hi everyone, this is Kenny Lee, and we're going to talk about Newton's first law. And to get things started off, we need to talk about one of my favorite scientists, and that's Galileo. He kind of got the ball rolling, quite literally, when he did a really simple experiment. He took sort of like a ramp, almost like a bow, and he rolled a ball down it. This ramp was very smooth. He rolled it down just to see how far it would go up the other side. He was kind of shocked to realize that it would come up to pretty much the exact same height he rolled it from. He thought that was kind of neat, but he wasn't sure if that would hold true. So he got a different bow, one that kind of stretched out on one side like this. And again, rolled that ball down, and amazingly enough, it rode to almost exactly the same height he released it from. And he did this for several ones, and he came to the conclusion that if you could get a ramp like this, and there was nothing acting on it, nothing to slow this down, then that ball would just simply keep rolling forever and ever until something caused it not to. He knew that there was something there impeding it, holding it back, so it would slow down, but he said if you get rid of that, it would just keep rolling forever. And he called that inertia. And he kind of got the ball started rolling with this demonstration of a ball. So after Galileo, Newton came along, and he took Galileo's idea, and he added this part where an object at rest will remain at rest. Now he called this the law of inertia. We later changed it to Newton's first law of motion, but inertia is key to this. And this law says that an object will remain sitting still or keep moving at a constant velocity until an unbalanced net force acts upon it. Well, first of all, what is a force? A force is basically any push or pull. So, if we push something, that's a force. So friction will be a force, and friction always opposes whatever's going on. So if I've got a block and I'm sliding it this way, friction will always act against the motion. And that's what slowed the ball down, is that friction. But he thought if we could remove that, it would just keep rolling forever. Newton said, well, if you've got something setting still, it will keep setting still, just as long as there's no unbalanced forces. In other words, as long as there's no net force on the object. Now, what is inertia? Well, inertia is an object's resistance to change in motion. And it's related to the mass of the object. So if something has more inertia, it also has more mass. Well, so this Newton's first law, it's about things either setting still or moving at a constant velocity. In order to do that, all the forces have to be balanced. So what does that look like? Well, let's say we've got two objects. Let's say we got this object at rest. For this object at rest, well, gravity's pulling it down. So I'll have an arrow pulling down. That's for gravity. In other words, let's say just call it its weight. Now, the table's pushing up on it. Now, we actually call that the normal force. And we'll talk more about that later on in a different video. But for this to be sitting still, those two have to be balanced. And there's no other force acting on it. That cancels out this. And so the net force is zero. All the forces are balanced. So this will remain sitting still. Now over here, we've got an object moving to the right at constant velocity. Well, we'll still have weight acting on it. And there's still a normal force from the table holding it up. But if I'm pushing this to the right, that's some force. Then if it's traveling at a constant speed, there's going to be another force friction that I have to overcome to keep this going. All I have to do with this force is cancel out that one. Then all the forces are equal. These two cancel out each other. These two cancel out each other. And so the net force on this object is 0. And so it'll just keep doing what it's doing. It'll just keep moving at a constant velocity. So if an object's at rest and all the forces on it are canceled, in other words, the net force is 0, it just sits still and it remains at rest. If an object's moving at a constant velocity, that means that, again, that all the forces are canceling each other out, and so it just moves at a constant rate. If this force was gone, and friction was the only one acting this way, it would be an unbalanced force, and it would affect the motion. It would slow this down. So, here's the thing. If all the forces are balanced, in other words, the net force is 0, the object will either remain at rest or move at a constant velocity. If the forces are not balanced, and any force can unbalance it. If we have more friction than we have pushing force, it will slow down. If we have more force than we have friction, it will speed up along this one. But if we have an unbalanced force, then that's going to change the motion of the object, and that's where Newton's second law comes into play. Newton's first law is when all the forces are balanced. Newton's second law is if there is an unbalanced force. And we'll get to that in another video. All right? Thank you very much, and have some more fun with physics. Goodbye.